Okay, this is 7.1 homework help. The first problem wants us to solve this equation. So we're going to rewrite this sine of x over cosine of x. So we're starting off with a really easy one times the cosine of x. When we multiply, we get the sine of x. So that's a pretty simple one. Next one, we have cosine squared minus 1 over sine. We're going to try to simplify that. We're going to use our Pythagorean identity, which is usually sine squared of x, but we can use any variable we want. So I'll use t here just to make it look similar. Now, cosine squared of t minus 1, if I move the 1 over and then move the sine over, what you're going to find is it's negative sine squared of t. So I'm going to rewrite this as negative sine squared of t over sine of t. One of these cancel, and your answer is negative sine of t. Okay, the next problem wants us to match these. So sine squared is right from our Pythagorean identity. It's sine squared plus cosine equals 1. So if we just subtract cosine, we can write it as 1 minus cosine squared, or if your formula sheet. So we want to look for that. And that's d. Okay, secant squared, that is also a Pythagorean identity on our formula sheet. In fact, I'll just show that to you real quick. Here's your Pythagorean identities on your formula sheet. So we're looking for secant, which is really 1 plus tangent squared right here. So I'm just going to write 1 plus tangent squared and look for that one if it's available. And that's supposed to be of x, sorry. 1 plus tangent squared is c. Okay, next cotangent is also, we're going to look for a Pythagorean identity that involves that. So cotangent would be cosecant minus 1 if I subtracted the 1 over. So I'm going to look for cosecant squared minus 1. And it's f. Okay, next is cotangent. Cotangent, I don't know how to write that a ton other than I could make it cosine over sine. Maybe that's, and it is, that's a. Okay, cosecant of negative x. We learned in the book or in the notes that I gave that this is an odd function. So I can rewrite it as negative cosecant of x. And so let me look for that, and that's b. The reason why is because negative or odd functions have this property right here. This is right off a formula sheet, where if you stick in a negative value, you get out the opposite of the original y value you get with a positive x. So, and this is an odd function, and we know that cosecant's really 1 over sine, and sine's an odd function, so cosecant's an odd function as well. So it does follow this property. All right, and the last is cosecant squared. So let's look for another Pythagorean identity with that. Cosecant squared is really 1 plus cotangent. So let's look for 1 plus cotangent, and that's L. Okay, we're going to want to try to simplify these expressions and see if they're equal, both sides of the equation. Now, I know you could, there's other ways to do this, but I'm going to do it this way because this is the way that's going to be the most helpful for the test. So I'm going to try to take this left side, usually start with a more complicated side, and see if you can simplify it to equal the simplified side. That's what we're going to do in the test. I'm going to say prove the trig identity, and so this is what you're going to do. So let's rewrite these all in terms of sine and cosine. So cosecant's really 1 over sine. Secant's really 1 over cosine. So dividing by a fraction is the same as multiplying by the reciprocal. So if I multiply by the reciprocal sine of x, I'd get sine squared of x. Multiply by the reciprocal up here, I'd get cosine squared of x. And that does equal 1 because that's the Pythagorean identity. So that's true. The next one, we're going to multiply cosine of x times, we have cotangent plus tangent. I'm going to put this all in terms of sine and cosine. So cotangent's cosine over sine. Tangent sine over cosine. And I should be able to simplify this further. So let's, I guess there's probably different ways to do this, but let's distribute the cosine. So I get cosine squared of x over sine of x plus sine over cosine, but the cosine is going to be distributed and cancel from the bottom, so you're just going to get sine of x. Now if I factor out a sine, I would get cosine squared of x over sine squared of x minus or plus 1. If you distribute, get back to what we started with in the top here. Now, cosine over sine is really cotangent. So that's cotangent squared of x plus 1. Now I'm going to look in the formula sheet and see if that's a Pythagorean identity. Cotangent squared plus 1 is really cosecant. So that really equals cosecant squared of x. Cosecant is really 1 over sine, so when I multiply it by sine, I get 1. So this thing really equals just 1. I'm sorry, I lied. This is just 1 sine. So let me rewrite this. This is sine of x times cosecant squared of x, which is really sine of x times 1 over sine squared of x. So one of these sines cancels one of these, leaving 1 left, which is really just cosecant of x. So that is true as well. So I know you could guess and check on this really easily within an infinite number of tries, and that's fine, but keep in mind that on the test I'm going to ask you to verify this trig identity. That's the way I would word this question. Okay, the next problem, we're going to simplify these. So taking the first one, we have tangent of x squared plus sine of x times cosecant's really 1 over sine. So these are going to cancel, and you're going to get tangent squared of x plus 1, which is one of the Pythagorean identities in our formula sheet right here. It's really secant squared of x. So I'm going to make this secant squared of x, and that's what I'm going to write right here. You probably want to enter it in like this, though. The next one's a little easier. Secant squared of x minus 1. That's right in the formula sheet right here. If we just subtract 1 from this, that gives us tangent squared of x. So that's just tangent squared of x. Next one's pretty easy as well. Make tangent sine over cosine. And so when you multiply by cosine, these cancel and you just get sine. Next one, same thing. It's secant's 1 over cosine, multiply by cosine, and obviously you just get 1. Next one, I have sine over cosine right here, so I'm going to rewrite that as tangent. And then times tangent just gives you tangent squared, so I'll write that as tangent squared. This one's a little bit harder. I'm going to try to rewrite this left side, start with the more complicated side, and see if I can get a quantity squared that I can then call f of t. So secant is really 1 over cosine minus cosine all over secant, which is 1 over cosine. Now I'm going to multiply by the reciprocal instead. So I'm going to multiply by cosine of t, moving that up. And then I can distribute, and that gives me 1 minus cosine squared of t, which 1 minus cosine squared of t, that's just sine squared from the Pythagorean identities. So that's really just sine squared. Now that equals what we're going to call f of t squared on the right side of this equation. So obviously the function is sine. So we just want regular sine here. Okay, the next problem gives us some more clues and wants us to set up a reference triangle and find whatever f of u would be. So let's draw what they're giving us. They're telling us we have an angle between 0 and 90, so I'm going to draw a triangle in there. Our angle u is somewhere between 0 and 90. They're also telling us that the secant of that angle equals x. So I'm going to write that as 1 over cosine of u equals x, and then flip it to write the cosine of u equals 1 over x. So that means this is 1 and this is x then, so that the cosine of u is 1 over x. If I do the Pythagorean formula, I get the square root of x squared minus 1 if you solve this Pythagorean identity. So then f of u equals the square root of x squared minus 1, which would be like opposite over adjacent. So we can say that's tangent, because tangent of angle u gives the square root of x squared minus 1 over 1, which is what they want for f of u. So f of u must be tangent. Okay, the next problem is a little different. They want the cosine of the inverse sine of x. Now the inverse sine of x is an angle. So I'm going to call that inverse sine of x equal to theta, because it is some angle. Then I can write the sine of theta equals x. Now I'm going to draw a reference triangle. I know inverse sine, if you remember, is defined from negative 90 to 90. So I know it's got to be here. Now it says it's positive, right? Because we have a positive value here. So the sine of this angle is positive, which means I can draw a reference triangle here. And I can label the sides opposite over hypotenuse, 1 and x. And then I can find the Pythagorean theorem. So it's a squared plus x squared equals 1 squared. Subtract x squared from both sides. and then square root both sides, and you have the square root of 1 minus x squared. So this is the square root of 1 minus x squared. And when they want us to find the cosine of that angle, this is theta, so which is what we called this. So the cosine of that angle theta is adjacent over hypotenuse, so it'd be the square root of 1 minus x squared. All right, the next problem then says let t be an angle between 0 and 90. So we're going to draw a reference triangle here. T is our angle between 0 and 90, so here's our reference triangle. It says the sine of t is 1/4, so that's opposite of our hypotenuse. If I do the Pythagorean theorem, I get the square root of 15 here. And now it wants the cosine of t plus pi. So adding pi would be making this a straight line because you're adding 180 right here. Where then, the hypotenuse is still 4, this side's 1, and this side's negative square root of 15. That's to be negative 1. So the cosine of that would be adjacent over hypotenuse, which is negative square root of 15 over 4. Now I'm going to do the last one real quick because that's the same angle, t plus pi. So the tangent would be opposite over adjacent, which is 1 over the square root of 15. Double negatives cancel. Now I'll do the minus pi one. So if we subtract pi, we're back at the same triangle. We just went the other way around. Subtracted 180. So if we wanted the sine of that, that would be opposite over hypotenuse. So it would be negative 1/4. And the last one is t plus 2 pi. So that just means we're going to start at our t value, and we're going to go around another 2 pi back to the same spot. So we're using this triangle again, and the cosine would be adjacent over hypotenuse, which is the square root of 15 over 4. Next problem wants us to put this in terms of cosine, which we're going to call c instead of cosine. So 1 plus tangent squared is a Pythagorean identity. It's really secant squared of x. So let's rewrite 1 plus tangent squared as secant squared of x. Now that's really 1 over cosine, so it's really 1 over cosine squared of x. That's really 1 over c squared then, if we're calling cosine c. All right, next one wants us to do the same thing, so we're going to FOIL this out. If we FOIL it out, we get 1 minus, the middle terms cancel, so you get 1 minus sine squared of x. 1 minus sine squared of x is your Pythagorean identity on your formula sheet, which is just cosine squared of x. So that's really just c squared if you use c for cosine. Okay, the next problem is a ton of algebra. Wants us to solve this. So I'm going to rewrite the left side first. I'm going to make this 1 over cosine of t minus tangent sine over cosine equals 1 over f of t plus tangent of t. Now I can combine these fractions. So on the left I have 1 over sine of t, 1 minus sine of t over cosine of t equals the right side. Now I can cross multiply. So if I cross multiply, I get this right here. And now I'm going to divide both sides by 1 minus sine of t, which gives me this. Now I'm going to subtract tangent from both sides, and I get this. Now I'm going to multiply both sides of this by 1 plus the top and the bottom of this by 1 plus sine of t to get rid of that fraction from the bottom. So when I FOIL the bottom, now I get this. Now 1 minus sine is really cosine squared of t. One of these cosines cancel. So now I've got this. And I can rewrite tangent as sine over cosine. So now I can subtract these fractions. When I subtract, these signs cancel, and I just get 1 over cosine of t, which is really just secant of t. And that's my answer because that equals f of t, which I solved for. So for the next problem, we're going to multiply this out and try to solve. So you get this. I'm going to replace the first thing with cosine squared because that's a Pythagorean identity on the formula sheet. So this is really secant squared on the formula sheet for trig identities. And this is really 1 over cosine. So when I multiply, I just get 1.